All right, let's talk about division of segments and angles. So for segments, we can divide a segment using a point, another segment, array, or a line. And if we divide it into two congruent segments, we call that bisecting the segment. And that point is called the midpoint of the segment. That point that divides it is the midpoint. Now, only segments can have midpoints because rays and lines are infinite, so they cannot be split into equal pieces because one piece is always going to be going off infinitely. And then we can use 2 points, segments, rays, etc. to divide a segment into 3 congruent parts, and that trisects the segment, and then we have what's called trisection points. And then again, only segments can be trisected because rays and lines are infinite. So let's look here. If O is the midpoint of CD, let's name the congruent segments. So in segment CD, that's from here to here, if O is the midpoint, remember the midpoint is the bisection point, which means O has bisected DC, which means that DO is congruent to CO. So DO, segment DO is congruent to CO. And you could also write those two segments as OD and OC because for segments the order does not matter. All right, let's take a look at B. We're told segment SW bisects segment XV. So it's bisecting XV, which means it is splitting XV into 2 congruent segments, which means W would be the midpoint. And our 2 congruent segments are going to be XW and VW, or WX and WV. So that is for segments. Now what about angles? We can also divide our angles into, if we are dividing it into 2 congruent angles, we're bisecting the angle, and then the ray that causes that bisection is the bisector. And then we can also divide an angle into 3 congruent angles, and that would be called trisecting. So again, bisect, think about a bicycle. A bicycle has 2 wheels. When we're bisecting something, we're splitting it into 2. Tricycles have 3 wheels. When we're trisecting something, we're splitting it into 3 equal pieces. So let's look at example 2. Name the congruent angles. So here, ray RO bisects angle NRP. So angle NRP has been split into 2 equal parts, which means that angle NRO is congruent to angle ORP. And again, we have multiple ways to name those angles. But those are my congruent angles, and I've also labeled it with tick marks. I did the same thing above with my segments. I used tick marks to indicate they were congruent as well. Okay, let's look at B. Ray XT and ray XV trisect angle SXW. So trisecting, remember that means we're splitting it into 3 pieces. So I'm going to have 3 congruent angles. So angle SXT is going to be congruent to angle TXV, which is also going to be congruent to angle VXW. So those 3 angles are congruent. All right, now on 3, we're naming the angle bisector. Remember, the angle bisector is what bisects our angle and splits it into 2 equal parts. So let's look at 3. Our diagram is marked with tick marks that tell us that angle FJG is congruent to angle HJG. That's what those tick marks tell us. HJG. So if those are my 2 congruent angles, that means that angle FJH was bisected by ray JG. So ray JG is the bisector. It bisected angle FJH. Okay, let's look at B. The measure of angle POK is equal to the measure of angle MOK. That means that those 2 angles are congruent. So if those angles are congruent, that means that angle POM was bisected by ray KO, or OK, right? So that would be how we identify our bisectors and trisectors. All right, we're going to switch gears a little bit now and talk about probability. Probability is a fraction or a ratio of our number of winners divided by our total number of possibilities. So our steps are simple. count all the possibilities, then determine the number of possibilities that are winners, what you're hoping to achieve. The winners go on top, the total possibilities go on the bottom. So let's look at this example 1. If one of the 4 large points is picked at random, what is the probability that the point lies on the angle? So we're already told that there's 4 large points, so that's my total possibilities. So my total possibilities is 4. What is the probability that one of them lies on the angle? Well, let's look at A. Is A on the angle? Yes. Is B on the angle? Yes. Is C on the angle? Yes. Is D on the angle? Yes. Then my winners is also 4. So my winners over my possibilities is 4 over 4, or 1. So you have 100% probability of picking a point that lies on the angle. But that's not always the case, so let's look at some other examples. On number 2, if one of the 5 angles is selected at random, what is the probability the angle is? So we've got 5 angles, so that is our possibility. Our possibilities, sorry, that's a long word. Our possibilities is going to be 5 for all of these. So 1, acute. Remember, acute angles are less than 90 degrees. So how many of these are acute? Well, A, B, and E are all less than 90 degrees. So my winners for acute is going to be 3. So my probability is 3 winners out of 5 total possibilities. Now let's look at B, right angles. I only have 1 right angle, and that is C. So my winners for B is only 1. So I have 1 winner out of 5 possibilities to get a right angle. What about an obtuse angle? Again, I only have 1 winner. So that's going to be 1 out of 5 possibilities. Now what about straight angles? Straight angles are equal to 180 degrees. I don't have any straight angles here, so my winners is 0. So I have a 0 out of 5 chance, or just a 0% chance of achieving that desired outcome. And that's it. Today's notes were short and sweet, so trisect, bisect, and probability. That is it.